Hello guys, in this video I will talk about Laplacian operator and you will face some kind of questions like that where you need to calculate the value of this. Now fr will be given, like let's say fr is what, let's say sin r, and r is what? R is not a variable actually it's a variable, not a single variable. It's a combination of x, y, z. So you can say r is nothing but the position vector. So this is, let's say, sin r or ln r or tan r or whatever. I'm going to show you for a general case where I will take that the function is nothing but fr. So the formula of this del square fr is f double dash r plus 2 by r into f dash r. Now in this video I am going to prove that, because in your exams you will face this kind of question and you have to find out the value of del square of sin r or ln r or tan r. You can use the formula and you can easily get the value in just 30 seconds. Because it's very easy to differentiate sin r, ln r or tan r. But the question will be fixed in around let's say 4 marks or 5 marks. So you have to show the proof. So you have to go through the proofs. That's why I'm not using the formula. I'm just saying that this is the formula, this is the final term. You can verify your answer after proceeding through the normal steps. So however, let's prove this formula. So how we can prove? You know what? That r is nothing but the magnitude of r vector. Let me introduce you with the r vector is equals to what? Xi cap plus yj cap plus zk cap, right? It's very easy. Now what is the magnitude of r? It is root over x square plus y square plus z square, right? So very nice. Now the thing is important. This is not fr, this is actually root over x square plus y square plus z square. Now the thing is del square. What is del square? It is Laplacian operator. But the thing which is important, del square is actually nothing but del dot del. And you know what is the value of del? The value of del is wait a moment. Value of del is what? This del by del x I cap plus del by del y. This is y j cap plus del by del z k cap. Now that's very easy. Now if we are doing dot product between two same quantities, then what will happen? We have to just make it something like it will be looking like del square by del x square plus del square by del y square plus del square by del z square. Very nice. This is the form of del square. Now you can proceed through the formula of del square actually. So basically we have to find out that, right? So first of all we have to differentiate this function with respect to x, then again with respect to x, and we will get a kind of quantity. And I don't know what is happening. Maybe there's a ghost and he wants or she wants to play with us. Ignore. So basically sorry, we have to differentiate this function with respect to x 2 times, then we have to differentiate it with respect to y 2 times, then z, as soon as possible. But we will do the differentiation for x, and when we will get the final result after differentiating with x, with respect to x actually 2 times, then after that we can replace x as y for getting the differentiation, the double differentiation or double partial differentiation with respect to y as same as for z. So you will proceed through the formula. First of all, the single derivation, differentiation. This is f dash root over what? X square plus y square plus z square, right? Into, now the thing is we have to differentiate the inner function, which is something like that. So this will be like this is root over x square plus y square plus z square. There will be a 2, there will be a 2x, and 2 will be cancelled out, so we will get something like that. This is the first step. I mean, this is the single differentiation. Now we have to do the double differentiation with respect to x again. So basically this is something like x into f dash. This is what? This is root over x square plus y square plus z square, right, and divided by root over x square plus y square plus z square. Very nice. Now we have to differentiate it again with respect to x. Now differentiate it. Let's so first of all, I am using the u divided by v rule. So this will be x square plus y square plus z square, root whole square, and root will be cancelled out, simple. So this will be root at the numerator. We will get something like, numerator is something like first let's say I'm using the uv rule now. So I'm keeping the x and differentiating the f dash. Okay, so x f double dash root over what, x square plus y square plus z square into this will be like x divided by root over x square. Basically I am differentiating this inner quantity, so I will get something like that. Hopefully you can understand, right? It's very easy. This line will be something like very much longer. So now I have to shift it a little bit at the right because I have not space. Wait a moment. Okay, now I can differentiate. So now this will be plus. Now I am fixing f dash x, not f dash x actually, but f dash, and I have to differentiate x with respect to x. So this will be f dash root over what, x square plus y square plus z square, right? Very nice. Bracket close. Now this is when I am fixing the numerator. Now I have to differentiate this is when I am fixing the basically I am fixing the denominator, I am differentiating the numerator. Now there will be a minus, and wait a moment, what is happening, I don't know. Space is very much less, so I have to increase the space. I am writing here, okay, hopefully not an issue, sorry. Okay, so now I have to differentiate this term and I have to fix this term, right? So this will be x f dash root over x square plus y square plus z square, bracket close, into the differentiation of this inner quantity actually. So this will be x divided by this same quantity, right? I am not writing here. Now basically I have to replace something here so that it will become a little bit like very easier, so that you can understand it. Now the thing is, r is equals to what, root over x square plus y square plus z square, right? So we can say that we can replace this term with r, something like this will be r, this will be x, bracket, this will be what, f double dash r into x by r, this will be x square divided by r, right? X into x square, right? Plus this will be f dash r, and well, very nice, this will be minus this will be what, wait a moment, well, very nice. Now this is this time I have to written, I have to, what I am saying, this time I have to write. So this is x, and this is x square actually. This is x square, this is f dash r. Now that's okay. This is r square, right? This is r square actually. Very nice. Now what will happen here, basically this will be x square into this r, and this r will be cancelled out for when I am multiplying this r with the first quantity. So this will be x square into f double dash r. Well, very nice. Plus this will be r into f dash well, this is what, x square plus y square plus z square, right? So this will be r, and we have to take the r here, right? Sorry for a mistake. And this is r f dash r, and this is minus x square divided by r into f dash r, right? Well, very nice. Whole divided by r square. Now the thing will happen something like that. When we are differentiating with respect to y 2 times, then we will get same thing, just we have to replace x as y. Now when we are differentiating with respect to z, then we will get same thing or same quantity, just we have to replace x as z. So I can use the step jump here, which is the denominator will be same r square. Now at the numerator we will get something like f dash r into x square, f dash r into z square, f dash, not f dash actually, it's f double dash or f double prime z square. So this will be f double prime or double dash r into x square plus y square plus z square. Very nice. Minus this will be, I am taking common the f dash r, so that I can get something like r minus, wait a moment, okay fine, this is r minus what, r minus x square divided by r. Now when I am differentiating with respect to y, wait a moment, then definitely I will get something like r minus x square plus y square plus z square divided by r, right? So this is r minus what, r square divided by r, and this is what, actually this is r minus r, which is 0. No, actually it is not 0. When we are differentiating with respect to z or y, then we will get 2 r's also. So this will be not r actually, this will be 3r, right? I mean r plus r plus r. So it is 3r and it will be 2r actually. So this is nothing but this bracket. Inside this bracket we will get something like 2r or something like that, right? Divided by r square. Now, oh well, so sorry, because r square is here already, so I can't use. Now ignore that stuff, you need to talk about this. How do we need to talk about this? Now this is again what, this is again r square, so f double dash r into r square divided by r square minus f single dash r into 2r divided by r square. Now this will be cancelled out, and this will be f double dash r plus this r and this r will be cancelled out or something like that will happen. This is 2 divided by r into f single dash r or single prime r. This is the value of del square f r. Now hopefully you can understand how I can get the proof very easily. This is the proof, and like, you know what is happening here. This proof is very much important because the examiner will provide you this kind of question, and you have to solve this kind of questions through the method which I have explained. Just you need to calculate the f dash r. Like in that case I have mentioned that the f dash r is f dash r. In that case, when you are dealing with any kind of function, let's say sin r, in that case you have to replace the f dash r or something like f dash root over x square y square z square or something like that with a kind of differentiation of sin r, single differentiation, which is nothing but cos r, right? If it is ln r, then 1 by r. Hopefully you can understand, right? And you can check your final answer through this formula which I have told you. at the beginning and at the ending. So thank you for watching my videos. Goodbye. In the next video I will talk about curl and gradient and irrotational vectors. So goodbye.